So let's see. So today we're talking about rendering and lighting and within Vectorworks. So, well, I have a lot to say about that. Most of which having to do with sort of the palpable and very real limits to my knowledge and expertise. So a few thoughts. One is this is always a tricky topic to do in a live presentation because rendering just takes so long and a lot of it is trial and error, and it's not really fun for people to watch your own renderings to render. It's even less fun to watch somebody else's render. So I've tried to do this in a way that is hopefully sensitive to your time. And the other thing is that there's just lots and lots of bits and pieces to good rendering and lighting, and I'm probably going to miss half of it. So hopefully this is more than just getting a toe wet. Maybe we're up to our ankles or to our shins, but I think I would be overselling it if I said this is like a super deep dive. Anyway, so with that, I want to talk about very briefly what the order of operations are for what I think are successful renderings. And the first thing, of course, that you need is you need a 3D model, which I just showed you the model that we're going to use today. And we'll also talk about, as we kind of get into the model, what constitutes a better model and some things to watch out for. In this case, you'll see I've got some structure rendered, I've got some site, various components. And so I've tried to pick something that gives us a variety of things to render, but you'll notice it's not actually a building, so there's no glass. that's strategic on my part, to keep render times reasonable. So then once you've got a model, you're going to want to adjust your surface appearances. So assign colors and textures, and probably if you do a lot of modeling, you already have classes and materials built into your standard Vectorworks workflows that addresses those. But once you have a model, you want to go ahead and add colors and textures to that model. So I want to point out that there's a couple of places here where I don't actually have textures, right? So the soffit here is a texture because I wanted to get that kind of grain in. But I probably could have gotten away, for everything that we're going to see, I probably could have gotten away with just making that a solid color. Certainly the steel structure is a solid color. Wherever I can, I've assigned solid colors to things and really reserve textures for places where I really mean to have textures, right? And depending on the scale of the rendering, for example, this kind of Ipe-like slatting, which has some problems with some scaling. Here, let me spin that around because it's kind of, we're on the dark side of the building here. If I pull back, you can see I probably need to play with the scaling on that a little bit. For certain views, I probably could have gotten away with doing that as just as a solid color, right? And then for others, not so much. And then once you've got your model and you've assigned colors and textures to it, then you're going to want to use Renderworks cameras for setting up your views. We'll talk about that. And once you've done that, you'll add your lighting. And there's sort of three general classifications of lighting. There's your ambient lighting, there's your exterior lighting, and your interior lighting. And I've listed those by sort of, degree of complexity and potential difficulty. So interior lighting is the hardest. And then finally, once all that's in place, then you'll go ahead and render your scene either as shaded renderings or using various Renderworks options and potentially even styles. And I've made all of this sort of as a kind of a linear recipe, but the truth of the matter is there's a certain amount of iteration going on. So after you do your rendering, you may decide that some of your textures are not all that, and you may want to go back to them. You may decide you've overlit the scene and change your lighting and so on and so forth. So that's the general order of operations, but you know, we're gonna be going back and forth, realistically speaking. So so here's a top view of the model that I just showed you. It's this outdoor pavilion that our office designed that got built a few years ago, and like I said, I thought it'd be a kind of a good candidate. So this is a real Vectorworks working file. I've stripped out all of the CDs, but this is the model that was used for that project. And then so from here, we're going to place some camera views, and we can either do that in a 3D view like this, right, or in a top plan view. Doesn't really matter. You can even place your cameras in a 3D view like a perspective. I don't find that particularly intuitive or easy to manage. So so I'm just going to go over here to let me move my attributes palette a little bit out of the way and kind of rearrange things because I've changed my screen resolution, so my palettes need to change. So over here in your visualization palette, I'm going to pull that out and enlarge that, right? And you can see that you've got your flyover, walkthrough tools, and so forth. Here's a Renderworks camera. So let me move that window over so that you can see what's going on. All right. So as I was saying, here's my Renderworks camera, and I'm just gonna pick a spot here and click and drag and point at whatever it is that I want to look at, and Vectorworks will go ahead and drop that camera in. Now, if I go to here, let's see. Turn on my visualization here. Okay, so you can you guys see my keystrokes as they're coming up? Like you can see a red dot when I drag that camera object. Somebody could unmute and let me know if you can see that.
We can see the control points on that Renderworks camera, but we cannot see what you're typing when you type.
Okay, so you're not seeing a red dot on the screen as I'm dragging my cursor around?
No, I don't see a red dot.
Okay, well then we'll just quit that useless app. All right, so so here you are. You zoom in. It gives the camera a name. I accidentally inserted 2, so there's my camera. And then let's look at that in the object info palette. There it is. So I can assign the camera to a class. That's if I'm going to leave the camera in the design layer where it is now. I can assign a height of the camera and where it's looking to. I can go back to a top plan view, which I already am, or I can activate the camera view. So if I click on that, then it's going to show me what the camera sees. And you'll notice it's got these little blue crop marks. Right. So that's useful. Go back to top plan view. Now, another way that I can do this, if you're not used to cameras and you're very used to sort of readjusting everything, just using your flyover and walkthrough tools and so forth. So a trick that you can do to set up your camera is just drop a camera, any old camera, into your design layer. And then I'm just going to go to standard view. if I can find it, like say a right rear isometric, and then I'll activate my walkthrough tool to give myself a perspective. And then I'll go ahead and set up my perspective with my flyover tool. I'll fine tune it with my walkthrough, right? All like that. Now, as I'm doing all this, the camera is still selected in the object info palette. And so what I can do is I can just match the current view. So when I do that, let's go back to top plan view. You can see that the camera has moved and shifted around. And now I can activate the camera view and I'm more or less back where I was, except with the crops. So let me go ahead and I'll render that. And this would be a good time for me to fine tune all of my classes. You can see like my ceiling is ghosted in, there's no roof, there's a bunch of stuff missing, right? So I'm just going to go back to a saved view. And in that save view, that's going to reactivate all the classes and layers that I want, but the camera object is still selected. So I'm going to go back to deactivate the camera view and then activate it. Let's go back to top plan view. Oh, it changed the view. Oh, that wasn't what I wanted. Let's undo that. All right, so let's go back to top plan view. Yeah, it sure did. There we go. Okay. So let's just deselect that camera, activate my view. Then I'll just go back to top plan, activate the camera or select the camera and activate the camera view. There we go. So now I've got all of the classes that I want. And you can see how the camera is cropping that, as I said before. So this is a good time to now use the fine-tune camera view. I can change, before I do that, I can change the aspect ratio. So by default, it's a 4:3. 16:19 is probably a better aspect ratio if you're anticipating sharing this with somebody on a monitor. Just monitors these days tend to be that ratio. In fact, if I hide the object info palette, you can see it more closely matches my screen. There's the little crop corners right here, these blue crop corners. That's what the camera is gonna make. All right, and now I can fine tune the camera view so I get this perspective control dialog box. I might want to move it over. Can you guys see that? Sometimes floating palettes don't show up in the screen shares. Okay, good. All right, so you can see that I've got these sliders and I can change very slightly, what the view height that I'm looking at. I can raise the camera, I can lower the camera. I can pivot left or right. I can change the camera distance, kind of come in a little bit closer. I can change the perspective. Right, and just keep fine tuning that until I'm happy with it. And then I hit OK, and it has adjusted the view for the camera to account for all that. So you can think of a Renderworks camera as in a way as in some ways it's like a save view, except unlike a save view, which is just sort of a macro, it's an actual object that sits in your design layer and will save various views for you. What the camera won't do is save a set of classes or layers necessarily. So I got something in the chat. What's going on? Okay, activate camera view button. So the question is if I could please explain the activate camera view button. So I'm going to go back to top plan view. And so this camera has a particular view that's associated with it. And if I go to top plan view, if I click on activate camera view, then it creates or it establishes the view that the camera sees. So that's pretty much all that does. So I can walk around here, right? And I can deactivate the camera view and then so it seems to be matching my current view, which is not what I want it to do. So let me go back to top plan view. Yep, so it's changed the camera because I had it selected. So I'm just going to do some undos. There we go. So I'm back to it. So if I just click on the camera and then hit activate camera view, then it just activates that view. I can go back using my back button to go back to a previous view. Could take a while. There we go. All right, move around just like I normally would, and then go back, select the camera, activate the camera. For render mode, I can assign a particular render mode to that camera. It did not match the classes from the other view. It's simply the camera won't change the classes. So once I used a save view to turn my classes on that I wanted, and then the camera will just display whatever classes are currently active. So there are no class controls embedded in the camera. So once I have my Renderworks camera set up, right, I can just leave it there on the drawing. I can option drag it and create a duplicate of it. I could then use this control point to change that. I can change the angle of the view. I now have another camera that I can activate its view and see what that looks like. So I can go back to top plan view and I can just sort of toggle between these two cameras, or 3 or 4 or 5, whatever. So once I have a camera and I activate the view, right, and I'll go ahead and shade that. There we go. So my camera is still selected, right? And what I'm going to do is I'm going to create, under the view menu, I'm going to create a viewport, just a regular viewport, not a detail or section viewport, just a regular old viewport. And when I create a viewport from a camera, or when I have a camera view activated, I should say, and I create a viewport from the camera, I get this dialog box, which gives me some different options. One is that I can link the viewport to the camera. So now the camera sort of gets appropriated by the viewport. It disappears from the design layer, as the dialog box indicates, and it becomes part of the viewport itself. And that's useful because then I can go back and edit that camera view and fine tune my camera view later, just as I would fine tune a camera view on a design layer. Or I can duplicate the camera and have the camera be associated with the viewport, but have its duplicate remain on the design layer. Or I can not link to the camera at all. I just saved this view, but there's no Renderworks camera associated with it. And the disadvantage to that is that I lose the fine-tuned camera view abilities that you get when you associate a camera with a viewport. So I'm just going to go with the first option. And then I get the regular create view dialog box. And I'm just going to create a brand new layer here, a new sheet layer. I'll give it whatever name. And I don't need a drawing label. I don't particularly care about scale, but that's fine. And then I can choose the detail level, low, medium, or high. Different Vectorworks objects like parametric doors, windows, and so forth have various levels of details associated with their 3D models, depending on whether the detail level is set to low, medium, or high. I don't believe I have any of those here, so it's in a sense irrelevant, but just know that that's in this particular instance, but that is going to be relevant in some cases, of course. And then I don't need to see any planar objects or any 2D components. And I'm going to mess with all the rendering settings, excuse me, later. So I'm not going to worry about this display settings side because that's kind of part of our talk today. So having done that, it's going to create a viewport on this new layer. It warns me that not all the layers have the same scale. Yeah, I get that because the site's at a different scale than the structure. That's fine. And so now I'm on a sheet layer. I'm no longer on the design layer, and here's a viewport, right, that I just created, and it's unrendered, but I can go ahead and update it. And so it's the exact same view as I had before. You can see it's pretty blurry, pretty low res. That's okay. What I want to point out is that you can see, I have to find it. Yeah, right down here in the object info palette, when I click on the viewport, it says camera, yes, right? So there is a camera associated with this view. And so again, I can double click on the viewport. And now this option to edit the camera that's associated, that's sort of embedded in the viewport, if you will, comes up. If I hadn't created this viewport with a camera object, then this would be grayed out. I couldn't do this. So I'll hit OK. And now I'm back to the camera itself. And so I can fine tune the camera view, right, as I did before. Maybe I want to play with the focal length. And maybe I want to look slightly more downward and maybe raise my camera height just a tad, whatever. Okay, maybe pan it a little bit this way. And so once I do that and hit OK and return to viewport, then you can see that the viewport will automatically reflect these changes that I made to the camera view. So that is one of the reasons why it's good to associate your rendering viewports with the camera, because as you work on your renderings, if you decide that you want to fine tune your views slightly, you can do that easily. All the other features of a viewport that I would normally expect, annotations, crops, and so forth, those are still there. So for example, I don't need all this ground. There is no crop. It's just going to use the camera crop initially. So I'll go ahead and draw a crop with the rectangle. Make sure I get everything. Yeah, come up. And since there's going to be some sky here, I might increase the crop a little bit above the building. So there we go. So you might be wondering, well, why am I going through all this trouble of setting up my viewports on a sheet layer when I could just go back to the design layer and just, I've set up all these cameras. I can just click on the cameras, activate the views, and do my rendering, and there we go. There's a couple of reasons for that. One is that in the sheet layer, you can see that I've got a default DPI that's associated with the sheet, and that's really useful. So this is what that viewport looks like at 72 DPI. And if I go back and edit the sheet layer, I can go ahead and edit that, and I'll change it to 144. So I'll double the resolution, right? And now the viewport is out of date, as you can see. So I'll click on update, and hey, look, it looks a lot better already. It's a lot sharper. So, so one of the techniques, and I'll harp on this a few times, I'm sure. One of the techniques that is really useful, given how long it takes for renderings to really get refined, is to start your renderings at a relatively low resolution. You don't really need much more than 70 or 80 DPI to be able to evaluate if your shadows are going in the right direction, or if your scene is overlit, or if the board form concrete texture here, see how that's not lining up among the two objects, right? So I can start to fix and refine my model at relatively low resolutions, and that is a huge time saver, because there's nothing more disheartening. Well, there are some things more disheartening, but there are a few things more disheartening than you hit render on a rendering. It takes 2 hours. You walk away, you come back, and it's pretty good, but you find some glaring mistake. So just as a workflow for kind of getting all the kinks out of your model, sort of as a shakedown cruise, it's really useful to start at a low resolution And then once you've got your textures set up the way you want it, once your model is, the geometry is correct, the textures and colors are correct, and the lighting is correct, then at the very end, you can go back and, crank up that resolution to, something bigger, like 240 DPI. Now I'm just doing a shaded render here. So even at 240 DPI there, it's already done. It's very, very quick, right? But when I get into some more high-end rendering options, those higher DPIs are going to really catch up to you, because every time you double the DPI, you quadruple the number of pixels, and therefore you quadruple the amount of time that it takes to render. The other thing I'll say is that, unless you're producing illustrations for an art book or for some really high-end print run, if you have a continuous tone of color, in other words, if you don't have a set of lines, but you just have a field of continuous color that, there's obviously variation within that field, your eye probably can't tell much of a difference between, say, 200 and 300 DPI, and you probably won't be able to see the difference between 300 and 600 DPI. So it might make you feel better to render these things at 600 DPI, but your output isn't really going to change that much because of the way that print heads work. The tiny little print heads print in these little rosette patterns, and they overlap somewhat. So there's an inherent almost microscopic blurring that happens as colors sort of move across each other. And so if you were to print a photograph at 300 DPI versus 600 DPI, it would take a lot longer to render, and the output would be almost imperceptible unless you're using a really, really high-end printer. So you really want to think about what your ultimate medium is for your renderings, and don't over render at a resolution that's higher than you really need. And these days, frankly, most of what you're rendering for is to output to images like JPEGs or PNGs or TIFFs or whatever, and share those electronically. So there you can get away with lower resolutions. Oh, something's popped up in the chat. So the question is, do I render my models in my working file or create a separate file with just the necessary model items? Okay, that's a great question. And there is not a one-size-fits-all answer. So it depends. So sometimes, for example, a few months ago, we've got a project under construction, and the builder asked us to provide the graphics for a nice big, I think 6x4 or 8x4 sign that they were putting in front of the project. So there was quite a large rendering. So for something like that, where the rendered file may end up being, hundreds of megabytes in size, we would just do that in a separate file. There's no reason to carry that around in your CD set. On the other hand, if you're doing some hidden line renderings or just some shaded renders like what I'm showing you right now to illustrate a project as part of your construction documents or your design development documents or something like that, then it's probably okay to keep the rendering within your main work file. It just depends if it's gonna bog you down or not. So usually we keep the renderings in the file. Occasionally, if they're really high output, then we'll put them in a separate file. Okay, so let's see. What do I have next? Yeah, so let's look at some different rendering options. So these are some that I obviously already have prepared, and we'll sort of dissect them. So this first one here is a shaded render, just like the one that I just showed you. And there's a couple of things about the shaded render that you need to be aware of. So let's look at those settings. So over here in the object info palette, you can see that the viewport render is shaded. Oh, and by the way, so there's a render, there's background render and foreground render, and that has nothing to do with the depth of field of the rendering. The background render is, every viewport has a background render, and optionally some viewports can have a foreground render. Those are, you could think of those as like the rendering underlay and the overlay. And so you could mix two different kinds of rendering styles. So for example, you could do a hidden line rendering on top of a shaded rendering if you wanted. And that's what those refer to. So all of these viewports only have one render mode associated with them. And so that's why the foreground render is set to none, and all of those settings are gray. They're pretty much the exact same as the background rendering. So you would use that if you have a viewport that you want two different rendering styles overlaid on top of each other. Right. So this is a shaded render. So in 2022, this replaces what's been heretofore OpenGL. It's very similar in terms of its output. It's a different rendering engine, but Vectorworks have basically tweaked it to look like OpenGL as much as possible for those of us who have been using that for years and years, since that's now been deprecated. And if I click on the background render settings, you can see these are my options. I'm doing high. For shaded, I don't really see much of a difference between high and very high. I'm using colors, textures, anti-aliasing, and I'm drawing the edges, which gives me this sort of black edge outline to everything. And I'm using shadows, and that's set to high, right? So this kind of comes to the next point in the kind of order of operations, right? We model, then we assign textures and colors, and now we need to talk about lighting. So let's go back to this model, back on the design layer, and let me peel back here, and let me just go to top plan view. So over here, I've got a heliodon, and so there's heliodons are available in the visualization palette. And right over here under your light object, or if you don't have Vectorworks Architect or Landscape or whatever, and you have Vectorworks Fundamentals, you could do something similar with a directional light. A heliodon is basically just a directional light that calculates the correct sun angles for a particular latitude and longitude and time of year. So in this case, I've got a heliodon that's indexed to the correct time of day. And you can see that I've got soft shadows and a physical sun and sky in some cases. And so when I'm in my rendering view here, I can change that from, say, March to June, and you can see that the shadows have changed, or November, or February, whatever. So in my shaded options, I'm in the design layer, but these are the exact same options that we saw in the viewport. I can turn off use shadows, and then it doesn't really matter what my heliodon's doing. It's not gonna cast shadows. And obviously without shadows, that's kind of a bit more lifeless. So I almost always go ahead and show shadows on my shaded renders, just a lot more lively. And so the heliodon is if you're just doing exterior renderings, so long as you don't want to do night shots where you've got glowing light in the windows and so forth. But if you're just doing exterior renderings, you really only need to think about two lighting controls. one of which is the heliodon or a directional light to mimic the sun. That's very, very simple, right? And the other is your ambient light. And so if you're in a design layer, under view, you would go to set lighting options. And you could correct, excuse me, you could insert indirect lighting. Now, all of these are not going to be used in a shaded render. So shaded render doesn't matter what you have, that's just going to ignore that. So I'm going to loop back to those later. You can turn on your ambient light. You can turn it off. You can see that as soon as I turn it off, the image gets quite dark, right? The default is about 35%. I find that sometimes a little bit dark. Maybe I crank it up to 60 or 65. And then for shaded renders and other render modes, I can also turn on ambient occlusion. And if you think about what a wall, like if you have a 90-degree wall, let's see if I can demonstrate this in the model. This is probably not a model that is very conducive to showing ambient occlusion. Well, yeah, you can kind of see it there. So can you see that there's a bit of a shadow line in the where the flange meets the webbing of that column? It looks a little bit a little noisy. This kind of random gray streak where the web meets the flange. Can you guys see that? That's what ambient occlusion is doing. It's sort of simulating the fact that those two 90-degree surfaces would be reflecting light off of each other, but it's really a simulation. It's not doing a bunch of light calculations. So it's kind of a rendering trick. If I go back and sorry, under my rendering style, if I go back, sorry, I mean to go to my lighting. If I go back to my lighting and I turn off ambient occlusion, look at what happens inside the column there. See, that just goes away. So ambient occlusion can make your rendering look a little bit more realistic without having a significant calculation penalty, because it just sort of fakes that in. So, so your ambient lighting is really important. And again, if I just turn off the sun, like right now the heliodon's selected, so if I delete it, then you can see models kind of flat. Now I have some other light sources in here, but other than that, this thing's kind of flat. So ambient lighting, heliodon, very easy to get some basic controls on your lighting with very little effort. So let's go back to that, to those day renderings, right? And let's look at the shaded rendering here. Again, to keep my rendering times quick in this demonstration, I've dialed down my DPI to like 72 DPI. Realistically, I might amp that up quite a bit. So if we, again, look at this viewport, you can see that I've got shaded, right? I'm using everything, textures, anti-aliasing, edges, shadows, and so forth, all on a pretty high level. And then if I click over here, there's a lighting options button. And again, it's just what we saw a moment ago in the design layer. I've got no indirect lighting because it's a shaded render. Even if I had these, it would ignore it. I have my ambient on, and I've turned on ambient occlusion. And the environment lighting, again, it doesn't matter what I have here because shaded rendering just ignores environment and indirect lighting. So any questions about the shaded rendering so far? I don't see anything in the chat, or you can just hit your space bar and unmute yourself and ask a question if you want. Okay. So here's another shaded rendering. It's pretty much the same. The only difference here is that I have turned off colors, right? And so that's what gives me this sort of colorless rendering. Now, I still have textures theoretically, though without color, these textures are, pretty much meaningless. But if I had something like translucent glass or opaque glass, that might show in this kind of a rendering style. So those are my sort of two potential ways to do very, very quick little renderings. If I want to get something that's a little more photorealistic, out of the box, I've got this middle option here, right? And you can see that the rendering quality is considerably better. I wouldn't quite say it's photorealistic yet, but it's certainly much more realistic than the shaded render. So let's go ahead and click on this viewport and point something out. So this is the background render here is a Renderworks style. So this is a pre-built style that ships with Vectorworks. It's a Renderworks style. It's realistic exterior final. So, what does that mean? Well, let's look at the lighting options. So if I click on lighting options, I now get this edit Renderworks style dialog box that actually gives me much more than just lighting. It gives me all the different options. So we'll just take those in order. The name is assigned out of the box, right? So I have 3 different broad classifications of renderings: realistic, artistic, or Redshift. And I'll talk about Redshift in a bit. Under my options, right, these are all of the options that are provided to me, generally speaking. So I can turn on anti-aliasing, I can turn on shadows or textures, blurriness, displacement mapping. Generally speaking, if you don't need an option, turn it off. So what blurriness does is it makes objects in the background blurrier than objects in the foreground. Displacement mapping, if your textures have some bump shaders associated with them, that would give your textures some 3-dimensionality. So for example, that board form concrete might have a groove or a reveal or a bit of an extrusion at the joints between the boards. Caustics are what are going to simulate the way light refracts and reflects through glass. So if you think about a glass sitting in a window with water in it and the sun shining through it, you get sort of a spot of sunlight on the counter, for example. That's what caustics does. And grass will have Vectorworks essentially take a flat surface and calculate, sort of create a kind of a grassy-like texture without having to model individual blades of grass. Caustics and glass are computationally very expensive. So if you've got your textures set up to take advantage of those, you're going to get some really great looking renderings, and the processing time is really significant. Displacement mapping, depending on whether your displacement map is self-shadowing or not, that's going to be more or less time intensive, and blurriness can also add a lot of time. So I'll just go ahead and look at one example. So let's go to our resource manager. And let's go to our textures. I'm going to find that concrete board form and edit that. And you can see that on bump, I have none. So I'll go ahead and add a bump to that. I'll select an image and I'll just reuse this colors texture. In other words, the color of the striations of the board form concrete is also going to inform the 3-dimensionality of the surface. And so I get a little preview of that image that generates the image projection back here, right? And I can give it a bump strength, or if I want to give it displacement mapping, then I can give it some height. I can set the bump strength to, you know, any value, right? As soon as I give it a height in displacement mapping, that overrides any bump strengths that I have over here. So we'll go ahead and give it a height of, say, 0.25. We could say, let's do the detail medium so as to not take forever. And if I did self-shadowing, that would look more realistic. The little extrusions of concrete between the boards would cast shadows, but it would also, of course, increase the rendering time. So if I do that, I've edited that. And I'm now going to update this viewport, and it may take a little bit longer than 6 seconds. So it might be difficult to see given the resolution here. So let's go back and sort of really exaggerate that. Get an inch, kind of ridiculous. Yep. Okay. And we'll see what that gives us. Not much difference. So, yep, I've got that turned on. So all of these, the quality is all set to high. If I had some glass, right, then I could limit the number of reflections. So glass reflecting on glass, reflecting on glass, that's computationally takes a long time. If I don't want a lot of computation time, I might even reduce that to 1, potentially even 0. I don't have any highly reflective surfaces here, and I don't have reflective surfaces facing other reflective surfaces. So that's not really an issue here. For lighting, again, this is what we've seen before. Now here, indirect lighting is being applicable. It is applicable because it's not shaded. It's a Renderworks texture or rendering mode. So I can have either 3 reflections of light as the ray tracing resolves itself, or 4 or 16. And as the name implies, probably want to stick to 3 or 4 unless I'm doing an interior scene where all of these surfaces reflecting light onto each other, walls, onto ceilings, onto floors, back onto walls. The more bounces you have, the more realistic that looks. And of course, the longer it takes to render. I can play with the ambient light. I can turn on ambient occlusion, right? Edges only applies to artistic Renderworks, and we're doing a realistic Renderworks. And then I can assign a background to this viewport, and I can have a variety of backgrounds that ship out of Vectorworks. The simple ones are just a color or an image, if you will, kind of like having an image in the background. The HDRIs, the different pixels have a different light intensity value associated with them. So if you have a piece of bright sky, it is actually going to shed a little bit of light onto your scene. Some dark sky will shed less light. And if it's bluish, like these, or even midday, it will give a decidedly bluish cast to your scene. So that's a sort of this dome that is rendered around your scene that simulates the sky. So in this case, we changed the sun angle, right? And another lighting consideration that's quite important is your light objects are controllable through your visualization palette, which I've got buried here somewhere. Let me pull that out. There it is. So the visualization palette will either show, come back here. It will either show your lights or your Renderworks cameras. The Renderworks cameras that are part of viewports are not listed here. These are just the Renderworks cameras that are in your design layer. So you'll notice that if I highlight the viewport and I click on my visualization palette, it lists all of the different light sources that are associated or visible in that viewport, and they either are on or off. So this is a daytime scene, so I've got some light objects in here. I've turned all of those off. And I want the sun to be on, obviously, because it's a daytime scene. And so my heliodon is turned on. Now, if I want to change the time of day, I can right-click on this and force select it. And then it will take me, might want to go to a top plan view. It will take me over to that heliodon. And so maybe I change it back to June or May. And maybe we choose 2 p.m. at 11 a.m. Yeah, okay, that's fine. And now I'm going to go back to my viewport. There's that view. And I'll go ahead and update that view. You can see it's got a bit of a bluish cast. It's calculating the ambient light. And the shadows have changed to reflect the sun position. Now you'll notice it also has this background sky, which the shaded render does not have a sky. Shaded renderings don't respond to, you can assign a background sky, but it will just ignore it, right? So my sort of workaround for that, if I want a background, is I just create a rectangle or polygon and give it a gradient, right? And just go ahead and stick that on the viewport and then send it to back so that it's obscured if I bring it to front. So, whoops. So let's send that to back. So that's how I'm getting a sky over here and even over here on this custom Renderworks. I didn't have a sky, I just faked it with this rectangle. So, so again, the Renderworks, the final quality Renderworks, which I've misspelled. The final quality Renderworks is that all of those are settings that just come straight out of the box. And to reiterate, all of these qualities are set to high. I get maximum reflection, 3 reflections, and so on and so forth. So I've deliberately made these relatively small because if you look at the size in the object info palette, this rendering is only 10 by 6 inches. If I were to make it 24 by 36 and 300 DPI, it would take a lot longer to render, right? So I made them small for purposes of quick demonstration times. But there are times when, in a scene like this, for example, I may not want a lot of reflectivity because there's just, other than maybe the TV screen hanging on the wall here, there's just not a lot that's terribly reflected. And so custom Renderworks is oftentimes a really good choice, and we'll go to those background settings because I can specify which of these I want to spend computational time on. I can change my reflections to a fewer number of reflections. Maybe I want my indirect lighting to be high, but my blurriness to be low, environment lighting high, and so on. So, as the name implies, I can customize how this renders. And so sometimes you can get a rendering with your custom Renderworks that looks virtually indistinguishable from a final quality rendering because you've selected, you've sort of turned off settings that aren't really important to you in that particular scene. And so that can save you some time. So again, these are tiny little renderings. There's not a lot to them, but the custom Renderworks is, 3 times faster than the final quality. The other thing that I've done with this one is I don't particularly care for the slightly bluish tint to the Renderworks. So if I go to my resource manager, one of the resource types that I have are my Renderworks backgrounds. So these are coming in directly, right out of the box. And one of the ones that comes with Vectorworks is this HDRI white. So it's essentially like a white sphere that encapsulates your model. And it is shedding white light from every direction. So you get this very, very diffuse, almost ethereal looking light in your model. But it's really quite bright. So oftentimes what I will do is I will just duplicate this background, and I will change the name to the duplicate, right? And then I'll right click on it and edit it. And I will go ahead and look at the options, and I will dial down the brightness and maybe the saturation to whatever percentage I want. Rotation doesn't really mean anything because it's just a uniform white surface. And so now, having done that, I can go ahead and assign under lighting options, I can assign this HDRI white 40% and then update that, and it won't be quite as bright. So you can mix, right, your HDRI background under background can be a light source, or it can just be an image, or it can be both. So in this case, let me go back to my custom Renderworks. Right, I'll go ahead and delete this rectangle. So under the Renderworks background, I can give it a say a simple sky cloudy, right? And that'll be the image that I see. But under my lighting options, I can have the background or the lighting from the background can be a different background than the one that you see. So the HDRI white 40% is shedding light on the scene, but what you're seeing as soon as I update is this sky. So the sky itself can potentially illuminate your scene or not. And then things like simple skies don't shed light ever. Any questions before I move on to the last mode I want to cover? All right, well, either it's totally clear or you're totally lost. So another option with recent versions of Vectorworks is this Redshift option. And so that's Maxon is a hardware and software rendering company that is a sister company to Vectorworks, also owned by Nemetschek. And so there's a kind of a tie-in. And so these Redshift renders that come out of the box, right? You've got this exterior fast, interior final, right? Or right up here, Redshift exterior final. So let's look at those options. So there's things called denoising. You can see that now that you've chosen Redshift instead of realistic, right? There's a slightly different set of options. For your quality, you've got high, very high, right? For lighting, again, similar ones, but not exactly the same. And then for the Renderworks background, again, you can change the sky. So it's just a different rendering engine. The Redshift tends to give you better results, a little bit better, and it's a bit slower. So in this case, and again, your mileage may vary, this takes a bit longer than the final quality Renderworks, so it's still rendering. Looks like somewhere along the line, there's like some little modeling artifacts here I hadn't noticed before. So, again, at 72 DPI with not a lot of glass, you may not really notice the difference. And so why go to the mat for 24 seconds when, you can get almost the same result 4 times faster. So it's good to really experiment with these and sort of get a sense of what works and what doesn't. There's some other benefits to doing your tests with viewports. So let's see, what's one that I want to play with? Yeah, I'm just going to option drag this. I'm going to kind of drag it off to the side here. So something that's interesting and destructive that you can do with your viewports is in your basic tools, you can split. So you can draw a line through a viewport. Sorry. Draw a line with your split tool through a viewport. So you've got, see how I drew that line and it divvied it up into another viewport. Here's another viewport. There's another viewport. So, you can go to my crop. So it's kind of like, it's just drawing a crop for you. So maybe I make this one as, instead of a realistic exterior, I'll make this one a custom Renderworks. And update it. Or on this next one over here, I might make that a interior final, even though it's not an interior scene. So in other words, playing with the crops on your viewports allows you to essentially do the same scene side by side. And you don't have to be so dramatic as to use the split tool. It's just kind of a nice little feature, right? So here I've got these 3 different versions, and so I can create little slivers, little swatches. I don't have to render my whole scene. I might decide, if I can figure out what that rendering will look like, say, within this band right here, right? Then that will be characteristic enough that it will tell me sort of what the quality of my model is. And so playing with the crop on your viewport to just render little swatches, if you've got a really elaborate scene that's taking a long time to render, that's a great technique for sort of previewing what your rendering might be. And then, when you're ready to go for the full rendering, then you change the crop. I've got some chat questions. Yep. All right. Thanks, Matt, for answering Tally's question. Yep. This will all be posted on YouTube. All right. So let's look at some night renderings real quick. And again, here I just did some shaded renderings and some custom renderings. Some of these are good, some of these not so good. So again, back to our friend, the visualization palette, you can see that I've in this rendering, I've turned off the sun, of course. There it is, right? And you can see that I have light 2, light 4, light 2, light 3, and light 4. So those lights keep repeating. And the reason that you're seeing light 2, light 3, and light 4 multiple times is because I've baked those lights into my symbols. So I think this is not a very convincing night rendering, in my opinion. And so if you want to do night renderings, shaded is probably not your go-to style, right? This one's considerably better. Still not great, but probably need to do a lot more work on it. So you can see, let's look and see what those, again, in the visualization, I've turned off the sun and all of these lights are turned off. Now, if I turn off light 4, if I uncheck one of these light 4s, you'll see that they all get turned off. So all the light 4s, it's a light that's within a symbol. And so it's like it's all or nothing. Every light in that symbol is turned off or every light is turned on. So it's really tempting to want to go ahead and put a light source, a Vectorworks light source in all of your light fixtures and and be really realistic with your rendering. And I would make the argument that that's not necessarily a good idea. So for example, one of the things that you could do is instead of creating a bunch of lights that shine up onto the ceiling, you could simply assign a glow texture to the ceiling itself. That's less realistic, but it's computationally a lot less intense. So that's a strategy that you will often see, is that people will create a glow texture. So it's just a color and it has some glow to it. And you assign it to your ceiling plane, whatever that's modeled from, with an extrusion or a floor or a roof face or whatever. And so that just sheds light as if light were shining up at it and it was reflecting down. And so a lot of times with renderings, it's what people expect to see rather than, what the correct physics. So let's go back and look at these lights real quick. So I'm going to go to the visualization palette. I'm going to go to light number 4, or light number 2 actually. And I'm just going to right click on that and force select it. So it will immediately take me to the design layer. And there's that symbol. And so I'm going to go and edit the symbol. Let's go to a wireframe view. So you can see that here it is rendered, right? Just these sort of hanging shade fixtures. And you can see that inside these shells or whatever, however we modeled these, right? There's a light object. Let me go to top plan. See if I can select it. There we go. So there's the light object. You can see that this is a spotlight. You don't want this to be a directional light or it will just shed. It's like the sun. You'll have, you know, it'll shed through everything. You can turn it on or off here, or you can do it through the visualization palette. Easier to do it from the visualization palette. The distance fall off can either be none. In other words, it will illuminate something 1,000 feet away just as well as it will illuminate something, you know, 2 feet away. You could have a smooth drop off, which is sort of a linear progression, or you can have a realistic fall off, which is an inverse square law, which is like the way physics really works. What you'll often find is that realistic fall off doesn't illuminate very much. And so you might choose to go smooth in order to get, again, not what the color, how the light really behaves, but how you would expect it to behave. And then you can see that there is an option to cast shadows, right? And you got to use this with a lot of care. Obviously, if you cast shadows with your lights, you're going to have a much more realistic rendering, right? So you'll notice that I've got some can lights in the overhead here, and they're shining down onto these chairs and these chaises, and they are not casting any shadows. So now that I've pointed that out, that probably looks a little unrealistic to you. The downside to not casting shadows is that you don't get that effect. And then the light will like go through walls, for example, because the wall isn't casting a shadow. So if we could flip around to the back, you would see a little penumbra of light on the back side of this pavilion because this little slat wall and the concrete wall back here is not stopping the light. So you really want to be careful that you don't have like 50 different lights in your model, all of which are casting shadows. Be selective. For lights that it's important to the scene for them to cast shadows, go ahead and have them cast shadows. So what I might do is make these 6 pendant lights here go ahead and cast shadows. But maybe the can lights don't cast shadows, or maybe the can lights are off altogether and I just throw some glow on the ceiling. Again, it's not necessarily the objective to be physically accurate, but to give you a scene that looks believable rather than, you know, is accurate. They're not necessarily the same thing. So here's again a Renderworks. I've just changed the sky settings and the background light and there's the Redshift. And again, the pretty consistent rendering times. They're about the same whether I have 1 light or 6 or 12. But you know, once you get high resolution, lots of DPI, large, you know, physically large renderings, a couple of feet across, and a bunch of glass and so forth, these things are really going to catch up to you. So you really want to be judicious about what you render and what you light. So some takeaways then. One is be sure and use your viewports because they're really great for generating both test renders and your final renderings. The nice thing about a viewport too is that it's saved, right? So if you close your file and walk away from it, it sort of documents all of the different changes, and you can try 6 different viewports of the exact same view side by side and kind of play with the lighting and see which one you like best. Start with a low resolution. I've been doing these at 72 DPI. Sometimes for very large ones, I might even go to like 36 DPI. And then once you've got your geometry down and your textures and your lights, then you start bumping up your DPI. There's some things that are going to just kill you on detail. So here's an example of that that actually was not too painful. This little assembly, this is the little cap at the top of the chimney here, right? So golly, do I really need to model that in order to have a nice rendering? Probably not. I also modeled this in two different ways. So one is computationally can be quite intensive, though that's really improved. This is a surface array for making that little mesh. This over here is just an extruded circle, just a cylinder that has a mesh render that I just got right out of the box. It ships with Vectorworks that's applied to it. So if I just turn off that texture, you can see it's just a solid, but the texture has some kind of mesh transparency built in. So there's no actual geometry here to calculate, unlike with the mesh. Another area that I find can really lead to some gruesome rendering times are plumbing meshes. So a lot of the plumbing fixtures out of the plumbing libraries are meshes. They can be really quite detailed, and that's nice, but meshes can be really intensive in terms of their rendering times if there's a lot of polygons to them, unlike NURB surfaces. So that might be okay if you've got one or two cars on your site model, great. But if you've got a multifamily project and you've got 6 plumbing fixtures in 20 apartments, that's just going to kill your rendering time. So watch out for plumbing meshes and turn them off if you don't need them in the rendering. The other thing I would say is really important, and this goes hand in hand with the viewports, is to experiment, try different things, play with light colors, color points. It is very much a trial and error process. Eventually, you sort of build a library of textures and lighting techniques that you like, but it is trial and error, and that's just kind of part of the process. And again, this is why you start coarse and then get granular later, so that you are free to experiment without spending days and days. And then please don't forget your visualization palette. It's really, really important. When you click on your viewport and you open your visualization palette, that visualization palette is associated with that particular viewport. So you don't need to have 6 different classes for your different light objects. You can just have one class for your light objects and then just turn them off and on in your visualization palette for that viewport. It's really key to making your file organization with lighting manageable, is to use your visualization palette. So really it boils down to communicate as eloquently as possible. Say as much as possible with your rendering with as few modeling components and lighting components as you can. Simplify your model as much as possible without minimizing your loss of intent. Again, I could get rid of that chimney cap and no one would ever know. If you don't need a texture, use a color. If you don't need shadows or a lit surface, don't put a light in there. Just because there's a can light in the closet in your reflected ceiling plan doesn't mean that you have to have a light object in the closet for your model, right? Go ahead and purge that. If you do need textures and light, use as few as you possibly can. So in that ceiling, in reality, we had some elliptopar lights that in the real world, in that actual project, elliptopar lights that shone up onto that ceiling. Probably if I was trying to put together a photorealistic rendering there, I might simply give that ceiling a glow, let the lights be there as props, but they're not actually doing any lighting. If you can get away with a custom Renderworks, don't do a final quality Renderworks. If you could get away with a final quality Renderworks, don't do a Redshift, right? Use the least computationally intensive rendering mode for what it is that you want to accomplish. And if a shaded render does the job, use a shaded render. And finally, I want to give a shout out to Dan Jansenson. Let me not obscure this QR code. There's about 30 short videos that he put together as part of his remarkable Renderworks book that's up on the Vectorworks website. So that QR code will take you to him, or you can search for Dan Jansenson, SENSON. He's really great at giving you lots and lots of good information about everything rendering in Vectorworks. He's really, pardon the pun, quite remarkable. All right, got a couple more minutes, and I see there's still a couple of chats. How do I turn off the mesh, says Dawn. Well, if it's just a spawn model to Tally's point, then I could just delete it, or I could just put it in a class that I turn off in my viewport. Yes, Tally, the split viewport is cool, and it's true of all viewports. You can use the split by line tool on any viewport. Sorry for not answering that earlier. I feel like I've just scratched the surface. I could go on and on about textures and displacement mapping and shaders and different nuances of lighting. But hopefully this is give you a bit of a toehold. But I would say, again, the most important thing is the strategy and to do things in the right order. Model, then textures, then lighting, then coarse viewports, then fine tune as you go. You will save a ton of time. So do a screenshot, grab this QR code, and go check out Dan's work. It's super useful, and he covers a wealth of subjects. That's just about it for me, unless somebody wants to unmute and lob out some more questions. Oh, there's another one in the chat. Oh, more in the chat. All right. Got some thank yous. All right, cool. Okay, everybody. Well, see you all next month. And thanks very much for attending. And it's been fun. Bye, everybody.